Now we study example number 3. Let's say we have one car here. Example 3 here. Okay, let's say we have one car. Okay. And then pulling a caravan. Let's say we have that caravan. Alright, and then we have string attached. Alright, we have string attached to the car and the caravan. And then let's say frictional force experienced by the caravan is 300 Newton, and then the car experience 500 Newton. And both car and caravan, okay, having acceleration equals to 2 meters per second. Alright, so the question is calculate the pulling force of the car. Okay, that is number 1. And then number 2, the tension. Okay, the tension of the coupling. Between the car and the caravan. Excuse me. Alright, let's say we have this kind of situation. So the car is actually moving to this direction since friction go to the other direction. This is friction, yeah? Alright, so now we need to calculate the pulling force of the car. The pulling force of the car. What is pulling force? Now, in order for the car to pull the caravan and that caravan move, the pulling force must be higher than the caravan. And for this car to move with this acceleration, then the force must be greater. Alright? But then in this situation, we need to calculate the combined resistance and the combined mass of the system. Okay, let's say we start with the solution. Question 1. So firstly, we calculate combined resistance. Combined resistance. Okay, so combined resistance, very straightforward. 500 Newton and 300 Newton. Okay, so the combined resistance would be 300 Newton plus 500 Newton. So we get 800 Newton. Okay, next we need to calculate the second one. We need to calculate, change the color first. We need to calculate the combined mass. Okay. So the combined mass is, I forgot to inform you the combined mass. The mass of the car. Okay, the mass of the car is mass of the car 1500 kg, and then mass of the caravan is 1000 kg. Alright, so the combined mass equals to 1000 kg plus 1500 kg. So we get 2500 kg. Now, because of these two things moving together, so we need to find the resultant force. Alright, we need to find the resultant force. So in this case, resultant force is, alright, resultant force means this F, the one that we yet to determine, minus with these two. That will be our resultant force. Alright, so resultant force equals to force minus 800 Newton. So what is 800 Newton? 800 Newton is actually frictional force. So to get resultant force, force that move forward minus 800 Newton frictional force. So we get resultant force. And then finally, we use this formula. Alright, formula F equals to ma. Right, that is what the final formula that we need to use. So in this case is, we need to write resultant force equals combined mass multiplied by acceleration. Okay, force, mass, acceleration. Force, mass, acceleration. Since our resultant force equals to this, therefore I substitute it here. F minus 800 Newton equals to the combined mass just now here, 2500 multiplied by acceleration. Here, the acceleration, 2 meter per second. So we get 2 meter per second. So when we solve this, we will get the value of force, the pulling force. So let we solve this. Okay, this one is 5,000 Newton, right? So we move this to the other side. We get F equals to 5,000 Newton plus 800 Newton. Then we get 5,800 Newton. So this pulling force is actually equals to 5,800 Newton. Okay, so that is part 1. So part 2, we want to calculate the tension of the coupling. Alright, meaning we need to find T here. What is that T? Now, to find the tension in the coupling, right? To find the tension in the coupling, we need to consider the car or the caravan separately. So let's say we consider one side first. Say we consider the caravan. Alright, the caravan, alright, net force for caravan only is tension minus 300 Newton. So what is this? This is what we are interested. And 300 Newton is the frictional force. And then if we consider the car side, then our net force will be T minus 500 Newton. Alright, T minus 500 Newton, and total of this we need to minus it with 5,800 Newton. Let me make that one clearer. If we consider the car, meaning we write here 5,800 minus the tension minus the friction. So why we need to minus the tension? Later we get back to that. So now we focus to this one first. We consider the caravan first. All right. So, and the acceleration of the caravan is now mentioned as 2 meters per second. This we get from the question. So in this case, net force equals to T minus 300 Newton. We still use the same formula. Okay, for force, we take net force. Net force equals to mass. Mass of the caravan just now is 1000 kg. And then the acceleration is 2 meters per second. Okay. Now, net force is actually equals to this. So we substitute in T minus 300 equals to 2000 Newton. So we bring this to that side. We get T equals to 2000 plus 300 Newton. So for the car, for the caravan side, we get 2300 Newton. If we consider the side of the car, we should get the same value. Okay, let's say we consider the car from the car side. This is from the caravan just now. So now we go to the car. Now we analyze the second side, which is on the car side. Okay, this is the let's say this is our car, and then this is the tension. This is the pulling force that we determine with the value 5,800, and then the frictional force is 500 Newton. So now we need to determine its net force. All right, net force equals to 5,800 minus 500 minus T. Okay, that is our net force. Yeah, one more thing I need to add is previously we know that the acceleration of the car is 2 meters per second. Alright, 2 meters per second. Alright. Then we use this formula, F equals to MA, and the mass of the car stated in the question is 1,500 kilogram. So we use this formula, F equals to MA, where our F is referring to the net force. Okay, net force. So we write 5,800 minus 500 minus tension equals to mass 1,500 multiplied by 2 meter per second square. Alright, we continue with this calculation. We get 5,300 minus T equals to 3,000. right? Then we move this to the other side. We get negative t 3000 minus 5300. So negative t equals negative 2300. Then we cancel the negative. We get t 2300 Newton. So you see the answer here is the same with the first one here. Now let us study example number 4. Okay, alright. Of course, we need to read the question carefully, and we highlight important information given in the question. A mass of 2 kg, it's pulled upward using a rope. The tension of the rod at that time is 30 Newton. Alright. Find the acceleration. Okay, this is what we want to find, the acceleration, right, of the mass. Then how much tension in the rope will produce? How much tension, that's another thing, in the rope will produce an acceleration of 2 meters per second square. Okay, that is our question. So now what we do, we need to draw a diagram to picture this problem. Let's say this is a pulley, and then there's a string pulling that side. And then from the question we know it is 30 Newton. So we write 30 Newton. And then a mass, right, there, with 2 kg mass moving upward. So the first question says, find the acceleration of the mass. Find the acceleration of the mass. Meaning we need to find the acceleration of this object. Alright, so first we need to find net force. Again, net force equals to 30 Newton, and force that exerted by this body downward. So that one we need to use weight formula, mg. So weight equals to 2 kg multiplied by, we take 9.8 here given to us, so we get 19.6 Newton. Alright, again this one go down, this one go to the other side, so two different direction. To get the net force, we minus the greater one with the smaller one. Okay, after we use that formula, right, this 30 Newton minus 19.6, alright, 30 Newton minus 0.6, we get 10 point. So the net force is 10.4 Newton. So next we use F equals to ma, because the question says find the acceleration. Alright, so F, we take 10.4 Newton. Alright, 10.4 Newton. And then the mass is 2 kg. And this is the thing that we need to find, acceleration. So we get 10.4 Newton equals to 2a. And then what is a? So a equals to 10.4 Newton over 2. So we get 5.2 Newton. So meaning this body will move upward with a equals to 5.4. 5.2 Newton. That is what the question wants. So now, next is we need to calculate how much tension in the rope will produce an acceleration of 2 meter per second. We are given 2 meter per second. Right? So we need to find net force. Again, net force. Okay, so I redraw again the diagram. Okay, this one is 30 Newton. This is the body just now. Okay, and then we need to find net force of this system, right? But how we want to find net force of this system? That's what we see just now. We need to separate the body into two different situations. Let's say I take from the side of this mass, from this object. Okay, we know that the mass is 2 kg, and then we know also its weight is W equals to mg. Just now we already calculated, we get 2 times 9.8, we get 16.9. So now, since the question says tension, so what we want to find is this T. What is this T? When the acceleration equals to 2 meter per second. That is what the question wants. So now we need to find the net force. The net force in this case is tension minus 16.9. Alright, so 16, sorry, it's not 16, 19. I made a mistake again here because I didn't copy it from that. This one is 19.6. Okay, 90.6. Okay, that is the net force. So we need to use this formula, F equals to ma again. Alright, since we are talking about this body, we are not talking about this because the question says how much tension in the rope will produce an acceleration of 2 meter per second square. Alright, 2 meter per second square. So F is T minus 19.6 equals to mass 2 kg, and the acceleration is 2 meter per second square. It's given here. Alright, so now we get T minus 19.6 equals to 4, and then T equals to 4 plus 19.6. Alright, so we get 23.6 Newton. Sorry. So that is example number 4.